block diagrams. If I'm taking a system and I'm drawing the transfer block diagram like this, with input as x's, the Laplace domain, and output as ys, I get the transfer function inside. This is just a pictorial representation of the functions performed by a system. Any system, any complex system, whatever be the system, let it be a complex satellite system or an aircraft or a reusable launch vehicle or your human body, finally it can be represented by a transfer function in this format. So it is a pictorial representation of the functions functions performed by a system. Okay, and also about the flow of signals, how signals are flowing. Like you have an input signal coming in, you have the output signal going out. So a transfer function is essentially a pictorial representation of the functions performed by a system as well as the flow of signals. Now the problem with transfer function is that many dissimilar systems can have the same block diagram, also same type of block diagram, and also same type of, whatever I say about block diagrams are equally same for the transfer function also. So many dissimilar systems can have the same kind of block diagram, which means that the transfer function gives you, that is the second point regarding the transfer function or the block diagram. Third point that I want to tell you is that the block diagram and the transfer function gives you the dynamic behavior of the system. How the system behaves with respect to time. Dynamic behavior is given, but physical construction is not known. Construction not given, not known, or not known means an idea, the information is not given. Okay. Fourth thing is that the transfer functions or the block diagrams are not unique. What do you mean by unique? It means that the same type of system can have different kinds of block diagram. It can be represented like this, or I combine this and write it as a single block, which means it is not unique. And fifth thing is, source in a block diagram is not explicitly shown, which means I do not know whether it's a voltage whether the source is a voltage, whether the source is a force, whether the source is a torque, whether the source is a push, a pull, or whatever. The source is not shown. So this is what I want to explain regarding the transfer function. It's a pictorial representation, as you already know. Pictorial representation of what? The functions that is performed by the system, each components in the system, as well as the flow of signals. Second thing is that many dissimilar systems can have the same kind of block diagram, which means I can say that this block diagram can be of a mechanical system. I'll just have 1 by s plus 1, etc. inside. Or it can even be an electrical system or a biological system, which means many dissimilar systems can have this, say, or even if it is an electrical system, it can be the transfer function of or the block diagram of a induction motor, or maybe it's a block diagram of an amplifier. But they may have the same kind of block diagrams. The block diagram is useful because it provides the dynamic behavior of the system, but it doesn't give you any idea about the physical construction. Another thing is that the block diagrams, or the transfer functions for that matter, are not unique at all. The same system can have different kinds of block diagrams, and the source in the block diagram is not explicitly shown. These are the things regarding block diagram that I want to tell you. Now, these are all, except for the pictorial representation, these are all equally applicable to, or the limitations or the characteristics of the transfer function as well. Okay, I'm going to a very important section which will be there with you all along your life. Now remember, closed loop system is the same as feedback system. Okay. Now, this is the basic diagram which you will be drawing a number of times in your class. You will have a forward element GS, you will have a feedback element HS, there will be a summer, this is called as a summer, this is a negative feedback, so I put a negative sign here, and this is RS, the input signal, and this is CS. Now this is the block diagram of a basic closed loop system where GS is the forward transfer function, HS is the feedback element, RS, this is the reference input, RS is the reference input. A motivating signal which is converted by a reference input is the reference input. Hence, we put it as RS. This is the output, which is CS. Okay. Now, two more signals I want to write is, one is BS, which is the feedback signal. And this signal is ES, which is the error signal or actuating signal. Now, this point, okay, this point is called as a take-off point or a branch point, take-off point. And this is known as a summer or a summation point. It is actually here what we are doing is this is not adding but subtracting. Okay, we are going to derive the closed loop transfer function. Closed loop transfer function means the ratio between the output and the input, or CS, overall output is CS divided by RS. This is what I am going to derive. What is CS? CS is equal to GS into ES. Is that clear? GS into ES. Because for this block alone, what is the output of this block? CS. What is the input of this block? ES. So CS by ES would be GS, isn't it? So I wrote CS is equal to GS into ES, equation number 1. Now, again, ES, the actuating signal ES is actually obtained by subtracting BS from RS, or RS minus BS on ES. That is what is being done in the summer. So, ES is equal to RS minus BS. Instead of BS, I can write BS in terms of CS, and because HS and the in the feedback, HS is equal to BS by CS. If you consider this block alone, the input is CS, and the output is BS. So I can write HS is equal to BS by CS, or this I can write as RS minus, instead of BS, I'll write CS into HS. CS, HS. Equation number 2. Okay. Now, I have these two equations, and then I'll write CS. What I'm going to do is, I'm going to substitute ES with this equation, so that I'll get CS is equal to GS into RS minus CS HS. Now remember to put S always inside the bracket. This is CS, not S into C. Okay. Now what I want is the relation between CS and RS as the transfer function. Now here I have CS here and RS here. Now rearranging the terms, I'm not going to do the rearrangement now. Rearranging the terms, what I'll finally get is GS by 1 plus GS HS. This is the equation which I'll rearrange the terms, and finally I'll end up with the transfer function. Overall transfer function is CS by RS is equal to GS by 1 plus GS HS. Now, if you just look into this, you'll understand that the overall transfer function CS by RS, now I have written in terms of this block and this block alone. Laplace transform of the output signal by Laplace transform of the input signal is equal to GS by 1 plus GSHS, where GS is the forward element, transfer function of the forward element, and HS is the transfer function of the feedback element. Remember, CS by RS is equal to GS divided by 1 plus GS HS. Now remember, this is the overall transfer function of any feedback system. Now, if I had put a plus sign here, I got a plus sign here by derivation because it was a negative feedback, and I'll get a minus sign here if it is a positive feedback. What do you mean by positive feedback and negative feedback? Hope you remember, in the summer I put a negative here, BSN. That if it is negative here, I put a positive here. And if it is a positive here, positive feedback, then I get a negative sign here. Just remember that. Okay, thank you. Bye.